Hello, I'm Dave Bogema, Senior Director of Product Management at VI Grade, and I'm going to be taking you through a recap of our recent VI Grade Zero Prototype Summit. The Zero Prototype Summit, or ZPS, is our annual 3-day flagship event. This is hosted at our VI Grade Sim Center in Udine, Italy, and is focused on the latest technology in simulation, driver-in-the-loop simulators, and hardware-in-the-loop for vehicle dynamics, NVH, ADAS, HMI, and motorsport applications. It's tailored to customers, partners, and prospects from global automotive OEMs, Tier 1 suppliers, universities, and research centers. It features customer presentations, live demos, software training, user groups, and numerous network opportunities. It showcases virtual tests towards zero prototype vision. So that's the zero prototype vision that VI Grade has created and been promoting, including simulation software, driving simulators, hardware-in-the-loop technology, and more. There were nearly 300 in-person attendees from 24 different OEMs and 17 different Tier 1 suppliers and service suppliers, and 6 different academic research institutions. We also had 27 industry sponsors. And I do want to take a minute to thank all of our industry sponsors. There's probably a lot of logos that you recognize up here. All the sponsors that were either present in our exhibition hall or at one of the simulator demonstration sessions. So we also had, of those 300 people, we had people from 23 different countries. In addition, we had over 1,200 people live streaming the event. So overall, over that 3-day period, we had over 1,500 attendees. A number of new products were announced and presented at this year's Zero Prototype Summit. But to put this in context, let's take a step back. 2 years ago, we announced the Compact Full Spectrum Simulator, our first step in our multi-attribute simulation journey. The Compact FSS is the first simulator to bring the worlds of vehicle dynamics and NVH together, combining accurate motion, vibration, and sound in a single simulator and simulation. In the Compact FSS, motion and low-frequency vibration are provided by the 4 corner leg actuators, and higher frequency vibration is provided in 7 degrees of freedom with shakers at the steering wheel, seat, and floor positions. Last year, we announced the Full Motion Full Spectrum Simulator, expanding on the multi-attribute theme and bringing together a 9 degree of freedom motion platform with the new HyperDock cockpit. The Full Motion FSS is the first and only real-time dynamic driving simulator that provides a complete experience of accurate full motion, vibration, and sound over the full spectrum from 0 to 20 kilohertz. The key enabler of the DIM FSS is the HyperDock. The HyperDock is the highly optimized carbon fiber cockpit with individual shakers at all driver touchpoints to deliver accurate vibration to the driver in 7 degrees of freedom, along with highly accurate sound. Both the Compact FSS and DIM FSS are already very successful, with several companies already adopting them in their development cycle. To date, 10 customers are utilizing the Compact FSS, and a further 4 have invested in the DIM FSS and HyperDock technology. In the last 10 years, VI Grade kept developing simulators with increased acceleration capability, minimized latency, and improved dynamic quality. We have made virtual driving more accurate, helping engineers make confident design decisions based on the feel and behavior of digital virtual prototypes. Now, we are launching a new product, the newest member of the VI Grade driving simulator family, and the latest step in the multi-attribute journey, the 6 degree of freedom motion platform, HexaRev. This is the HEXAREV, a completely new 6-degree of freedom motion platform with ultra-low latency and near-silent operation. The HEXAREV platform is VI-Grade's most advanced motion system to date. It combines mechanical innovation with a simplified design to deliver a driving experience that is smoother, quieter, and more immersive than anything previously available. At its core, HEXAREV is a high-performance, high-precision, 6-degree of freedom platform capable of generating exceptionally accurate vehicle motion. With no gears, belts, or ball screws, sources of mechanical play, latency, and noise are eliminated. Motion is immediate and virtually free of unintended spurious vibrations. The HEXAREV offers a significantly larger simultaneous motion envelope compared to traditional 6-degree freedom systems. Traditional platforms experience a reduction in motion range when multiple degrees of freedom are active, making complex maneuvers less realistic. In contrast, HEXAREV maintains a larger motion envelope even during complex multi-axis movements, delivering about 50% greater motion envelope capability relative to its footprint. Here in these plots on the left, we have the motion envelopes for simple motions of a HEXAREV and a traditional 6-degree of freedom motion platform of similar size, where they have similar overall motion envelopes. But as we move to the right side of these plots, where they have, you can see that they have more simultaneous motions in all degrees of freedom, and the HEXAREV maintains a larger overall motion envelope when we have these combined motions. This makes it ideal for simulating realistic driving and vehicle dynamics with simultaneous movement across all degrees of freedom. Now let's take a closer look at the architecture that powers the magic of HEXAREV. The system is built around 6 motors concealed within a circular frame, each connected to a carbon fiber rod. These 6 elements work together to drive a platform that supports the cockpit, ensuring seamless motion control. This design guarantees a nominal payload of up to 800 kilograms, delivering exceptional performance and stability. Combining the HEXAREV motion platform with the HYPERDOC cockpit results in a full spectrum simulator. This integration marks a significant step forward in our commitment to multi-attribute simulation, enabling engineers to better evaluate ride, handling, NVH, steering feel, and other critical attributes within a single unified environment. It represents the next evolution in our technology roadmap, pushing the boundaries of what's possible in virtual vehicle development. With the combination of HEXAREV and HYPERDOC, we deliver a driving experience that sets a new benchmark for realism and precision. The system provides true 6-degree of freedom motion to replicate vehicle dynamics with exceptional fidelity, along with vibration across all driver touchpoints, ensuring that every nuance of road surface and vehicle response is accurately conveyed. Complementing this physical realism is an immersive and precisely engineered audio environment that captures the full spectrum of vehicle and road sounds. Together, these elements create a seamless simulation experience that enables engagement with digital prototypes as if they were real vehicles. One of the key features of HEXAREV is its modularity with existing VI-grade technology. In particular, it allows for seamless switching between compact, HYPERDOC, and racing cockpits. Add to this VI-grade zero latency technology, and the result is an unmatched simulation environment where human drivers can experience ultra-realistic driving sessions with their digital virtual prototypes and make critical design decisions with confidence. With HEXAREV, VI-grade has redefined motion simulation, introducing major advances in motion envelope, responsiveness, low noise, and mechanical simplicity. Integrated with a hyperdock, VI zero latency, and the VI grade ecosystem, Hexarev delivers a high-fidelity driver-in-the-loop experience. So the next major announcement from our 2025 Zero Prototype Summit is VI Data Drive Cloud. Vehicle development is more complex than ever, with deep software integration and a need for realistic, large-scale simulation. That's why we built VI Data Drive Cloud, a cloud-native platform offering scalable computing, centralized data, and team collaboration. Fully integrated with VI Car Real-Time, it enables parallel simulations for high-performance runs, DOEs, and diagnostics, breaking hardware limits and accelerating insights. With support for plugins, FMUs, and actuator extensions, as well as customizable post-processing, it's built for real-world development at scale. This is part of VI Grade's Data Drive vision, where offline simulation, driving simulators, and cloud computing come together to fully support the digital workflow, enabling and accelerating the development of software-defined vehicles. VI Data Drive Cloud gives you scalable and efficient simulation, increased flexibility, better teamwork, and ultimately gives you the answers you need for faster decisions. And the final product announcement for the 2025 Zero Prototype Summit, we have the compact HMI simulator. HMI studies are often carried out on static vehicle bucks or bespoke mock-ups that are only suitable for that vehicle type. When adjustable mock-ups are used, they're often only that, adjustable mock-ups, able to assess positioning and content of the HMI systems, but not including any capability to really drive the vehicle and assess the HMI under driving conditions. The compact HMI simulator is designed to accelerate HMI development by merging flexible interior simulation with realistic, real-time driving experience, AI-powered traffic scenarios, and hardware-in-the-loop and software-in-the-loop integration. The compact HMI simulator is highly adjustable and provides the ability to simulate the driving position for many different types of vehicles in a single simulator. The wheel and dash height can be adjusted along with the wheel angle and position. The pedals adjust vertically, fore, aft, and laterally. The seats also adjust in all three translational directions. And all of these adjustments can be controlled through a tablet touchscreen interface, and saved configurations can be recalled and applied in an instant, enabling quick transitions between different vehicle setups. The compact HMI simulator can adjust to the seating positions of virtually any passenger car vehicle, from sports cars to SUVs. Provided with 3 screens for customizable content, any number or type of screens can be easily added and positioned in the cockpit. The thing that really sets the compact HMI apart is not just its flexibility, but that it is also a complete, fully functional, interactive, real-time driving simulator. So HMI functionality can be tested not only on a static mock-up, but also in action in a variety of different driving scenarios with different weather conditions and different traffic conditions, and even combine this with ADAS features. VI SimSound completes the experience, adding immersive sound to the driving simulation. And the compact HMI simulator can be equipped with a virtual reality or augmented reality technology to further increase immersivity and provide the ability to see the virtual mock-up of the virtual prototype interior. Now, I also wanted to take a moment to mention the VI grade virtual proving ground. While not a new release of the 2025 ZPS, it is a recent release and a very powerful and valuable addition to the entire VI grade product suite. The VI grade proving ground is a virtual proving ground consisting of all common proving ground tracks and features in a single unified virtual proving ground track. And all demonstrations of the 2025 ZPS were utilizing the VI grade proving ground. In fact, in this virtual proving ground contains over 50 kilometers of roads, 13 different tracks for driving areas, and is suitable for the entire range of excitations and events. The VI grade proving ground is suitable for our multi-attribute simulations and our full spectrum simulators. The proving ground is a full spectrum proving ground, supporting a variety of types of virtual testing from handling and ride to comfort up to NVH, vibration, and sound. The VI grade virtual proving ground is integrated with all of the VI grade software products and is ideal for virtual testing of vehicle dynamics, NVH, HMI, and ADAS. Here's an overview of the virtual proving ground, and I can quickly take you through all of the different areas. To start with, we have our central hub. And this is actually a virtual representation of our VI grade sim center in Italy. We have our high-speed ring. The longest straight here is 2.5 kilometers. We have a highway section that is 2 kilometers long that represents both EU and US highways. So one direction and one set of lanes is for EU highways, and the other direction and other set of lanes is a US highway with all of the appropriate signage and so forth. We have our comfort lane section. This is also 2 kilometers long. It's got 6 lanes of various different surfaces to provide different excitations to the vehicle. So it's got a flat surface, coarse asphalt, smooth asphalt, and so forth. Next, we have a ramp area with 6 different incline or ramp sections. We have our ride lanes. Here we've got 9 different lanes with various different features on those. So cleats, speed bumps, and Belgian blocks, and sine waves, and so forth. We've got a handling track with curves and high-speed sections and low-speed sections. We've got a rally track and a country road. Now, this country road is actually a real country road that exists in real life. It's been laser scanned, so it's an accurate digital representation of a real road. It's about 2.5 kilometers long. Of course, we have a open area here for doing vehicle dynamics testing. Also has a section with split view lanes with different friction coefficients on each one. We have a wet handling area and an ADAS test area. So the VI grade virtual proving ground provides the visual environment and track surfaces for almost any type of virtual testing you may require. All right, so getting to the presentation section of the Zero Prototype Summit. Over the course of the 2 days of the Zero Prototype Summit, there were more than 30 presentations demonstrating how automakers and their suppliers are making strides towards achieving the Zero Prototype vision, showcasing advances in vehicle dynamics, NVH, ADAS, HMI, and motorsport applications. I'm going to share just a few highlights with you today. So first is Porsche engineering. Porsche engineering is leveraging modular, standardized XIL, or everything in the loop architectures, to accelerate and streamline development and validation across the entire automotive lifecycle. The team showcased how simulation, AI, and big data integrate with early, continuous, and automated testing, from software in the loop to driver in the loop. Their simulation environment relies on clearly defined interfaces and reusable components, enabling seamless model exchange across SIL, HIL, VIL, and DIL. Use of ASAM standards like OpenDrive and OpenScenario ensures interoperability and tool-independent reuse of scenarios and tracks. Procedural track modeling pipelines create high-fidelity, simulation-ready 3D environments within minutes, supporting scalable and reproducible testing. Driving simulators are used to bridge virtual and real testing, allowing validation of complex driving functions such as ADAS and handover situations. So here, the team's challenge had to do with increasing system complexity and the need for efficient, traceable, and scalable validation, which posed limitations to conventional test methods and simulation toolchains. Integration gaps and non-standardized components slowed down their development cycles. So Porsche engineering implemented a modular, standardized simulation framework using VI-grade tools, integrated with their in-house ecosystem. This setup supports consistent reuse of track, scenario, and vehicle models across all XIL levels and utilizes procedural 3D track generation for rapid environmental creation. So some of the benefits of this, they have faster development and validation thanks to this scalable and automated test execution. They have tool chain independence through standardized data formats and interfaces. They get high realism and reproducibility in virtual testing environments. They have immersive early stage function evaluation using advanced driving simulators. And they get strategic alignment of XIL tool chains as innovative enablers of future mobility. So next up, I want to highlight the Bridgestone presentation. So here, digital transformation is key to tire innovation. Bridgestone is investing in virtual tire development workflows to reduce prototype iterations and development time. The emphasis here is on sustainability. Virtual methods help minimize physical testing, cutting down on material waste and energy consumption. Simulation accuracy is crucial. Achieving fidelity between simulated and real-world tire behavior is central to reducing reliance on physical tests. VI-grade tools are enabling end-to-end virtual tire evaluations, including dynamic driving performance in simulator environments. The integration of virtual tires in full vehicle simulation environments allows better OEM collaboration and earlier design alignment. So traditional tire development requires extensive physical prototyping, leading to long lead times, high costs, and unsustainable resource use. Ensuring accurate prediction of real-world performance was also difficult. So Bridgestone implemented a virtual tire development process, leveraging VI-grade simulation platforms, including VI car real-time and driving simulators, to test and validate tire models early in the design phase. So out of this, they get a 60% reduction in prototype iterations. They accelerate development timelines and improve collaboration with OEMs. They get enhanced sustainability by cutting physical testing and material use. And they improve prediction accuracy of dynamic performance and customer satisfaction. Next, we have EDAG. EDAG has launched a dedicated zero prototype lab in Wolfsburg, combining virtual development, real-time simulation, and cross-domain engineering to eliminate physical prototypes. This lab includes a DIM 500 high dynamic simulator, a compact full spectrum simulator, and desktop tools to enable scalable simulation from early stage model function testing to full vehicle dynamics and NVH evaluation. EDAG integrates digital twin methodologies for simulation-based tuning and validation across domains like steering, NVH, lighting, suspension, and tire development. This unified simulation pipeline allows a 10,000 times faster virtual loop, drastically improving tuning cycles and enabling development decisions under repeatable conditions. The emphasis here is on multi-attribute development. Vehicle dynamics and NVH teams work jointly, supported by tools like the HyperDoc for immersive feedback and validation. This lab enhances sustainability, reduces development time, and supports safe and fast tuning without the need for physical prototypes. So EDAG realized they needed to reduce time and cost associated with physical vehicle prototyping while maintaining high accuracy across complex domains like vehicle dynamics, NVH, and lighting. Conventional development processes lacked integration and flexibility for fast iteration. So EDAG built the Zero Prototype Lab, a virtualized test and development facility powered by VI-grade simulation technology. It supports real-time, multi-domain simulation using high-fidelity models and dynamic simulators integrated in a closed-loop workflow with digital twins. This provides massive efficiency gains with up to 10,000 times faster simulation loops in the development stages. It provides reduced reliance on physical prototypes, leading to cost and time savings. They get high-fidelity results through one-to-one queuing and repeatable simulation setups. They achieve cross-domain collaboration on a unified platform, which improves tuning quality and reduces siloed workflows. And all of this results in safe, sustainable, and scalable vehicle development from concept to validation. And finally, we have a presentation from Ford Germany. So Ford utilizes the VI-grade NVH desktop simulator and NVH compact simulator at their Cologne Development Center for the NVH development of the new electrified Ford Puma Gen E, enabling virtual evaluation and sound prototyping early in the development phase. The simulator was used to oralize and subjectively assess analytical data, drastically reducing the need for physical prototypes. 75% of the final propulsion sound design was developed virtually. Key sound design challenges included tonal sound characteristics of electric vehicles, which differ significantly from traditional internal combustion engine vehicles. Simulation bridged the gap between objective acoustic metrics and subjective perception. The team used the simulator to iterate designs rapidly, test transfer functions, and simulate real-world conditions using TPA modes. A high correlation was achieved between simulator outputs and real-world vehicle measurements, proving the accuracy and reliability of virtual NVH evaluation. Simulator-based clinics involving Ford management and customers helped refine the propulsion sound to appeal to internal combustion engine customers, creating a fun-to-drive sound feedback experience. So the big challenge here is that electric vehicle NVH differs significantly from internal combustion engine NVH in tonal characteristics and acoustic masking dynamics. Ford needed a fast, accurate, and immersive way to develop and refine sound quality targets for the Puma Gen E. especially in early development stages, without relying heavily on physical prototypes. So they implemented the VI-grade NVH desktop simulator and VI-grade compact simulator to perform oralization, design iteration, and sound quality evaluation, integrating active sound design into this process. The process included subjective, objective alignment, TPA modeling, and automated data processing to optimize efficiency. So the result, they were able to do up to 75% of sound design and get that finalized in a virtual environment. They could do same-day subjective evaluations, supporting fast decision-making. They achieved improved efficiency, realism, and cross-functional collaboration. The active sound design helped position the Puma Gen E as an emotive, sporty, battery electric vehicle that appealed to traditional internal combustion engine drivers. The NVH simulator has become a standard development tool at Ford globally for NVH target setting, design, and development. And one of the things that this enables is the easy sharing of virtual prototypes and design proposals globally with other Ford development centers. It's very easy to take a virtual model and send it in just a few minutes to another development center for somebody to listen to. All right, so we're getting close to the end here. Now, I want to let you know that we are holding 2 additional Zero Prototype events this year. So one is going to be in North America and one is going to be in Japan. So please join us for these events to experience live demonstrations of our real-time driving simulators and software and expert talks on simulation-driven vehicle development inspired by the ZPS Summit in Italy. You can visit our website to learn more and sign up. And for more information on the 2025 Zero Prototype Summit and to watch the full recordings of all presentations, please visit the vigrade.com or scan this QR code. So all of the presentations that were given at the Zero Prototype Summit, including the ones that I briefly summarized here, are all available in their entirety on our website. You can watch them completely unedited there. All right, and with that, I have concluded our presentation. So thank you very much for your attention.